Okay, so these problems here demand a lot more room, so I'm not going to use the worksheet for the solutions on this. And let me just get those out of the way. All right, so the first problem is in this homework, x minus 1 over x plus 2 is greater than 0. So in this problem, we have an x in the denominator. So a little differently, we need to make sure it's set to 0, which it is. And we also need to make sure we only have one fraction, and we do. So it's already set to 0, and we've got one fraction. So therefore, my critical points will come from both when the numerator and the denominator are 0. So my critical points are x equals 1, I can write today, and x equals -2. You put down your number line, -2, 1. There is no equal to on this, so everything's an open circle. If I pick -10 as a test point, I'm going to substitute this in for x, and I'll get -11 over -8. We don't really care what the number is. It's just that it's a negative over a negative is a positive. These signs will alternate as a shortcut because each of these powers are odd. So it's going to go positive, negative, and then positive. Where the inequality is greater than 0 is where the number line is positive. Everything is pretty obvious. So then it's -infinity to -2, and then from 1 to infinity. Number 2, it is already set to 0, and it is already factored, but it's less than or equal to. So again, my critical points come from when the numerator is 0 and the bottom is 0, and that is at x equals 3, -2, and -1. So you got to put them in the right order, otherwise your signs will be off. Now, because of the equal to part, this is a little tricky, this part, but it's not hard. The denominator can never include that critical point because you can't divide by 0. So no matter what, the critical point from the denominator is always an open circle. Those critical points from the numerator will get the closed, that is -2 and 3. So the denominator critical points will always get open circles, but because of the equal to, the numerator critical points will get the closed. My test point, again, is -10. Substitute that in for x, and we want to keep track here. So we have an odd number of negatives being multiplied and divided, so the overall sign is negative. Because each of these signs are odd powers, the signs will alternate. Negative, positive, negative, positive. Where am I less than 0 is where the number line is negative. So now my final answer is from -infinity to -2 bracket in union with 1 to 3 bracket, but parenthesis at 1. -1, sorry, -1. Number 3, x minus 3 squared times x plus 2 over x minus 1 cubed is greater than 0. It's already set to 0 and it's already factored. So my critical points from the top are 3 and -2, and from the bottom it is 1. I'm just going to put them in the right order, -2, 1, and 3. And because there's no equal to part, everything will be an open circle. Everything is an open circle. And now I'll pick my classic number, -10. Now, -10 minus 3 is -13, but squared is a positive. -10 plus 2 is a -8. And -10 minus 1 is a -11. Cubed is a negative. So those signs multiplied and divided will become a positive. Now, let's see if I can figure out the rest. Because this critical point came from an odd power, I'm going to alternate to be a negative, and the 1 came from an odd power, so it's going to alternate back. But the 3 came from the even power, so it's going to remain positive. So now my answer is, where is it positive? Where is it greater than 0? From negative infinity to negative 2, and from 1 to 3, and from 3 to infinity. Let me show you the longer way. Is you don't have to do the shortcut. You can pick a test point between each of these. So from negative 2 to 1 is 0. That's your test point. You put 0 in, and you'll get a positive times a positive, and 0 minus 1 is a negative. Cube is a negative. So then I'll get a negative for that area. And then from 1 to 3, I can pick 2 as a test point because that's between 1 and 3. Put 2 in for x. You just have more computation to do. And anything squared is a positive. That's a positive. And 2 minus 1 is 1. Cubed is a positive. So positive multiplied and divided is a positive. And then obviously if I pick something beyond 3 like 10 and sub that in for x, I'm going to get a positive. So you don't have to do the shortcut if it's too much to keep track of. And number 4, in this one, we're going to need to subtract 1 from both sides. And I'm going to have to get a common denominator. So I'm going to times this side by x plus 1 over x plus 1. And I'm going to distribute 2x minus 1 minus x minus 1 all over x plus 1 is less than 0. 2x minus x is x minus 2 over x plus 1. So let me just recap that algebra again. We had to set it to 0 by subtracting 1, and I have to have the same denominator, so I times it by x plus 1 over x plus 1. But then you have to distribute that minus sign through to get minus x minus 1, collect like terms, and that's what I have. And it's pretty easy because, again, to get those critical points, set the numerator and denominator equal to 0. So I'm going to have here what? Minus 1 and 2. And everything's an open circle because there's no equal to part. So as a test point, I'll pick negative 10. And negative 10 minus 2 is a negative 12. Negative 10 plus 1 is a negative 9. So a negative over a negative is a positive. Because these powers are odd, it will alternate positive, negative, positive. Where am I less than 0 is where the number line is negative, because that means graphically the graph is below the x-axis. And my answer is from negative 1 to 2. And 5 and 6 are kind of the old problems. And number 5, it's already set to 0, but I got to reverse FOIL this into, I'm going to try 2x and x, and 2 and 1. And that's going to be the minus, and that's going to be the plus. I do need that because the outer is negative 4x plus 1x is negative 3x. So my critical points now are negative 1/2 and 2. You can just set that equal to 0 and you get negative 1/2. So put down negative 1/2, put down 2, closed circle because of the equal to. No denominators here to worry about. If I pick negative 10, I'll get, put this in for x, and I'll get what? There are negative 19 times a negative 12 is a positive. And very simply, I know that these signs will alternate. Where am I less than or equal to 0 is where the number line is negative. So it's a bracket at negative 1/2 to 2 with the bracket. And number 6, the last polynomial one. It's already set to 0. I'll take out the GCF, and I'm going to reverse FOIL that into that. So it's got to be x minus 4 and x plus 2. My critical points are 0, 4, and -2. So put down -2, 0, and 4. And because there's no equal to, everything's an open circle. All right, let me pick -10, no surprise. Put this in up to here. It's a -10 times a -14 times a -8. And an odd number of negatives multiplied is a negative. But guys, as a shortcut, because of all of these powers being odd, from those critical points, the number line will alternate. Negative, positive, negative, positive. I'm answering the question of where it's greater than 0. So where is the number line positive? -2 to 0, and then from 4 to infinity. In number 7, we're given a graph, and the graph, to be quick, sort of looks, I'm not going to worry too much about, exactly matching it. And this is the 0, -2, this is at 1, and this is at 3. So number 7, the x's for which the function equals 0 is where the graph hits the x-axis, and that's at -2, 1, and 3. In number 8, the x's for which the function's positive, that means where is the graph above the x-axis from? And that's going to be -2 to 1, and then from 1 to 3. You cannot simply say from -2 to 3, because at 1 it equals 0. In number 9, for what x's is the function less than or equal to 0? Where's the graph below the x-axis? That's from -infinity to -2 bracket. I've got to include it now because it's equal to 0, and it equals 0 at -2. So here it's all above, it's above, this is below, and this is below from 3 to infinity. And the cumulative review questions in prep for the exam or the test. Number 10, the equation of a line perpendicular. I definitely need to solve this for y by subtracting 3x. This is a -2y. Well, let's just divide by -2 then. And y equals -2 plus 3/2 x. The slope of this line is 3/2, but I want perpendicular, so I need its negative reciprocal, which would be -2/3. So the point it's passing through is -3, 2. So it's going to be y minus 2 over x minus a -3 equals -2/3. I'm going to cross multiply. And there's my answer. I think you're all pretty good with that. Number 11, the end behavior of this rational function. Before you spot the, if you will, the leading term for this end behavior, you take the leading term of the top, which is x cubed, and you take the leading term of the bottom, which is -x. Again, the term with the higher exponent. But these reduce to give me -x squared. So I have an even power, negative leading coefficient, so it's flipped upside down. So that's going to describe the end behavior. So as x's approach infinity, the f of x's are going off to -infinity. And as the x's go off to -infinity, I'm sorry, as the x's go off to -infinity, f of x's go off to -infinity as well. They both go off to -infinity. Even power, they've got to go off in the same direction. And last but not least is number 12. Find all zeros of this function. So we're going to set it equal to 0. I'm going to add 9. And I'm going to divide by 3. You undo a square by plus or minus its square root. And then I'm going to add 1. So my zeros are √3 plus 1 and -√3 plus 1. And keep in mind that √3 is over 1, getting closer to 2, because √4 is 2. So this is like over 2 and some change. And this is actually at some negative 0.7 something, probably in some change. And that concludes the solutions to assignment 13. But the biggest takeaway is on solving the rational inequalities. I hope that